Down here, the next pattern, division expands as subtraction. So if you come down here to these log properties, when you have log with a base of b, base of b, and then you keep the argument of an m right there in the center, that means multiplication. So like we just wrote, multiplication expands as addition. And then you would have log, base of b, n. So this one was the rule, division expands with subtraction. So log, base of b, m. Remember, division expands as subtraction. Log, base of b, n. This one, you can put this exponent in the front, so it's k log of b, argument of an m. So that pattern is the exponent can be written in front of log as a multiplier. So I'm going to jump to this page 2. So this is page 2. And so I am just a reminder, multiplication expands as an addition. Division expands as subtraction. And then you can move your exponent in front. So those are 3, and just know they can go back and forth. So like if you see this one has addition, which is right here, it can go back as multiplication. So in other words, you keep your log with a base of 6, and instead of adding, you're going to put that 4 times 9. I can get rid, since they're both the same base, that's why I can do that. So then that would become log, base of 6. 4 times 9 is 36. Go ahead and add your equals x. We've been doing this for a while. So 6 to the x power equals 36. And then we can rewrite that as 6 to the x power equals 6 squared. When you have the same base, you can cancel those bases, and your answer is x equals 2. So let's do this next one. Reminder, you can go back and forth with these rules. So in other words, I see subtraction right here. So when I see subtraction, I can go back and make it into a division problem. So you take this log of 5, you only have to write it once because you're combining it, and then you're going to have 100 divided by 4, which I'm going to go ahead and bring down my log 5. 100 divided by 4 is actually 25. That equals x. We know how to write that. 5 to the x power equals 25. So let's get our same base. So 5 to the x power, change the 25 to a 5 squared. Mark off those common bases, and x is 2. So then let's jump down and let's do number 9. This is the one where you have your exponent that you can write now in the front. So now that is 6, and then log 2 with an argument of 32. okay? I'm going to ignore the 6 for just a minute and continue with the rest of the problem because I know how to do that. So 2 to the x power equals 32. I'm going to keep the 2 to the x power and change this 32 to 2 to the 5th. Mark off those common bases, and you have a 5 there. But remember, I've kind of left out this on purpose. So now I have 6 times, because that's what it means when it's in front up there, and the answer I got there was 5. So 6 times 5 is 30. Okay, I'm going to go ahead and do these. You do true and false to see if these are actually written right. So if you look on this side, remember when you think addition, you need to think multiplication. So I can keep the log. Instead of adding, I have 3 times 7. So that would be log of 21. And that's what they said I got. So this is definitely true. So the next one, I'm going to do this side over here first. Let's see if I can get that. So remember, when you have subtraction, you need to think division. So I'd have log of 9 over 3. If I break that down, log of 3. That does not equal the log of 6. So this is false. Let's go to D. So I'm going to start on this side, and I am going to put this, bring it back here. So what that would be log of 4, and it's not just a negative, it's a -1. Remember, negative exponents mean you drop it. So you keep your log, and instead of the 4 being there, the 4 drops into the bottom, which it does check to that, so that is definitely true. Let's go to E, see what we got here. Remember, addition should make you think multiplication. So let's write log, and then I'm going to have 5 times 3. So that would be the log of 15. It does not equal the log of 8. So this one is also false. Okay, next one. I am going to start with these two. Addition should make you think multiplication. So here we go. Log, and that would be 25 times 2. So that is the log of 50. And then I'm going to go ahead and bring this one down. Okay, so now that you see subtraction should make you think division. So now I'm going to have log, and then I'm going to have that 50 over that 5. So when I reduce that, I'd get log of 10. And that is what I wanted, so that one is true. So that is the first 2 pages of that day.